step 2, and we're going to solve this equation using Vieta's substitution. So now we can apply Vieta's substitution to transform our PQ cubic equation, this y to the power of 3 plus p, y plus q equals 0, into a quadratic equation. And if I scroll back up, basically what I showed here, basically if we apply this substitution, this Vieta substitution, y equals z plus a blank divided by z, just any number there, or the one we're going to eventually determine, and it's just function like this. To transform it, and then we're going to get a z cubed plus a number divided by z cubed dot 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 equals to 0, and we can transform this into a quadratic equation. So let's apply this, and let's just write the variable k for that number above z. So let's just write our pq form of the cubic equation. So y to the power of 3 plus py plus q equals to 0. And now we're going to do let y equals to this Vieta substitution z plus, and we'll write k over z. So we have this, and now what we'll do is we're going to get a, put this inside, so we're going to get a y is going to be a z plus k over z, then cubed plus, now we have a p, so now we have a p, and then we're going to get a z plus a k over z, and then plus a q equals to 0. All right, now this is pretty straightforward, so we're going to just expand this all, and now the idea is going to be we want to get rid of this pz, get rid of this one with all the z by itself terms, so get rid of these ones there. And also find the value of k to get rid of those. So we could expand, let's just expand all of this out, because it's super quick, we're using Pascal's triangle. So this is going to be z cubed. Now we're going to get a plus a constant 3. So again, remember Pascal's triangle right here. So it's power of 3. It's going to be 3, then 3, x squared, and then the other one's x, the other one's 1. So we're going to get a constant coefficient 3. Now we're going to get a z squared times it by, so z times z. Now this one times it by k divided by z. K over z. All right, so we get that, and then plus the next one's going to be plus another 3. And now we're going to get z multiplied that once, and then this one's going to be twice. It's going to be k over, k squared over z squared plus pz. Oh no, the next one is just this times itself, 3 times so k cubed over z cubed plus, and now pz. So you need to go through all this. All you need to do is just determine the ones with the pz, and so this is all that matters. I'll also write this for completeness, multiply this inside just because it's pretty easy. And as k, p, and then this is z, or and then plus q equals 0. So what we want to do is we want to cancel this one out with, and now what we'll see is we cancel this out. This and this cancel, so now we're left with a 3z. And then there's a pz. So all the terms with just a z term, because this one will cancel, but we'll have a z at the bottom. This one is at the bottom, a z at the bottom. This one's no z, and this one's z cubed. So all this is the only ones that we matter. This and this. So this is going to be now. This would equal to. This is we'll get a 3z k, and then move this this plus pz equals 0. So we want to cancel. So it's the same thing as a PQ method, but now we're doing the zeta method. It's the same thing PQ, but we're using, or the Vieta method using the z, and plus k over z. So want to cancel. So we want to cancel. That's it. So then, in other words, we're going to solve for k to cancel to make it equal to 0. So we're going to move this over to the other side. We're going to get equals to a negative. All the z cancels first. So cancel, just divide it all out. And now we're going to get move this p to the other side. So we're going to get a k and divide by 3. So k equals negative p over 3. So there it is. So that's our k value. All right, so this would cancel with the negative p over 3. So now we can plug this inside here and then do that again. But we already expanded it. So let's just use this and just replace all the z's. So now we're going to replace it because we know it cancels. We could see that. So it's going to be now negative. So negative z cubed, and this one's going to be z cubed by itself. Doesn't change. And then plus, this one's already canceled. So this one's going to be, I'll just remove this one. And then this one is going to be, this is already canceled. So I'll just put a blank like that. So this is plus canceled. And then the next one's 3z. then the z cancels here, and this one. Now we're going to get a k. K is going to be, well, negative p. So negative p over 3. And there's a z there, like that. The next one's going to be plus k cubed. So that's going to be a negative, and that, oh, this one's going to be k squared. This is going to be plus, because it's a negative squared plus. And this is, you have to put a squared there. This is going to be a 9. All right, and now the next one's going to be this one here, k cubed. Now it's going to be a minus, because we have a minus cubed. It's going to be just minus 1. Yeah, so it's going to be minus, and now we're going to get a p cubed over, and then 3 cubed is 27, and then z cubed. Like that, and then plus pz, oh, the pz's gone. So pz is cancelled. So that's this one, and this one's cancelled. I'll just remove those out. And then plus, and then that's going to be kp. So it's going to be minus p squared, because it's p times p, and then divided by 3, and then z plus q equals to 0. So we did that instead of putting it in and multiplying it out again, putting this in and expanding it out. And so let's do it like that. So now the next setup is, yeah, see what we get next. This one is going to cancel. This is going to be a 1. This is going to be a 3. So in other words, it's going to be this one here. That's a plus. So then this cancels with this. So cancels. Yeah, so this cancels. And this cancels. Yeah, so that's gone. Now all we're left with now is a z cubed, as the Vieta substitution stated. We're going to get a now p3 divided by 27 z cubed plus q equals to 0. And now this we can convert into a quadratic formula, and to do this, well, there's a z cubed. We want to, and this one is z cubed at the bottom. If we multiply everything by z cubed, so let's multiply everything by z cubed. Yeah, so I'll go dot z cubed. What we end up getting is we're going to get a, I'm going to put the z cubes in a bracket for our substitution. So it's going to be z cubed and then squared. So that's times z cubed. It's going to be z to the power 6 or z cubed. Or just z cubed squared. And then now this one, move it over to the other side. This one's going to be a q, because this one has the z cubed term. So q and then z to the power 3. And now what we're going to do is minus, because this one we got rid of all the z cubes. So get rid of them all to get rid of them. And we're going to get a p3 over 27 z's gone, equals to 0. Now this is a quadratic equation. And we could see this by, well, if we recall it a quadratic equation in the PQ format, so recall quadratic equation. And if we recall, we had, and I'll put this in the PQ format, so x squared plus, I'll do capital P, because we already have lowercase p over there, then x plus capital Q now equals to 0. And again, this is if we scroll all the way back up to our PQ format. And this is when we had it over here, quadratic formula. All right, so yeah, there's the quadratic formula and PQ substitution method. And again, we converted over this right here. This is, we can divide it out, so we get this x squared plus px plus q equals 0, and then shift it over, and then we end up getting is this x equals negative p over 2 plus or minus square root p squared divided by 4 minus q. All right, so then recall this one, and the solution is going to be x is equal to, it's going to be now negative capital P over 2 plus or minus square root, and now we get a, it is better, plus minus square root and p capital divided by 4, and then minus q, like that. Here, so quickly scroll up, and again, yeah, negative p over 2 plus or minus square root p squared divided by 4 minus q. Again, just to double check that. That's the exact one. Negative p over 2 plus or minus square root, and then p squared divided by 4 minus q. So we get that, and now if we look at this right here, this is exactly it. Now this one's going to be our x, z cubed is going to be our x, and then the q is going to be our p. Now this capital Q is going to be this negative p over 3 divided by 27. So in our case, we get x, well, yeah, so basically the x variable is going to be equal to or equivalent to, because not equal to, just because we already have an x before. I'm just saying in this case, is equivalent to z cubed. So yes, we have x squared is z cubed squared. And then the next one is going to be capital P is equivalent to lowercase q. And then the next one is going to be capital Q is equivalent to negative P3 divided by 27. So what this means is, so then this x is going to be z now, z cubed, is equal to negative P divided by 2, so that's going to be Q divided by 2, plus or minus square root, and now this P squared divided by 2, that's going to be our Q squared divided by 4, yeah, not 2. And that's going to be, I'll put it like this. And this is going to be divided by 4. And then minus Q is going to be plus, lowercase p cubed divided by 27. Alright, and now let's just box this in, just for completeness. Okay, so we've boxed in our z cubed function there, so we've solved it using quadratic formula.